Hello and welcome to our second CAD video for this course. The aim of this video is going to be to show you a lot of the basic tools for creating two-dimensional sketches, which we can then extrude or stretch into the third dimension to make 3D objects. And we'll make combinations of these things to make complex 3D forms. So the first thing we're going to do is make sure that we can create a new design. We'll start off with a simple sketch, and then we'll save it just so we have a copy. Just to remind those of you that haven't seen it, if we go to the top left of our screen, yours may or may not already be open, but the last top left button is the data panel. I click this button, I can see show data panel. Again, you may have a bunch of projects. I have many different projects, but you should find yours. If you have not already created it, you can click the new project button. But once you have a project, you have area where all your designs show up, and right now you don't see any of my designs because they're hidden within folders. There's this new folder button. So if you want to compartmentalize your designs, which is not a bad idea for the notes and practice that we do together in these videos, and then maybe also have folders for different assignments that you create. So I have a folder I called notes, so I can click new folder, it'll ask me for a name, and I can type in a name. I think that's a good idea to keep your stuff separated like that. And then if you want to make sure your design is saved into the proper folder, just double click on the folder and go into that folder. So you can see I already have a design in this folder. And this area right here called the breadcrumb trail or file trail tells us where we are. So the home location, my project, and then the name of the folder. So the design I'm going to make is going to end up in this folder. So it's a good idea to separate your things if that's what you think, if it's going to help you manage your data better. So now that I have this, I can go ahead and hide the data panel. So what we're going to do is I'm going to show you on our Google Classroom in the Sketches and Modeling Basics area, we have an option called Tutorial Couch Diagram. We're going to be trying to recreate from a 2D drawing a 3D model. And so I'll say some things about this particular design. The first thing that I want to point out is this is a isometric or a 3D view of the thing we are going to make. Most drawings or drafts of 3D objects don't typically put measurements on the 3D drawing. There's typically a flat drawing, a front view, a side view, a maybe top view, where different measurements are laid out. And then there's a 3D view that just gives you the overall sentiment, what it looks like. But generally speaking, we don't put measurements on a 3D model. This particular diagram that I have does not conform to that, but other ones will in the future. So this is something that's not standard, but we're going to use it as our kind of starting point so we can get a sense of what we're doing. And in the future, we'll see other ones, and your assignments will probably have 2D and, views and one isometric view, and I'll show an example of that at the very end of this video. So we're going to try to recreate this. So we can notice some things. We're using millimeters for all of our measurements, and we can follow along with this. So to start, what we kind of have to do, and we don't have to do this, but it's not a bad idea, is to kind of establish, well, what is the overall shape that I want to create on this object? And my suggestion is if we were to look at this from the side, like our angle was going this way, we would see kind of a trapezoid of some kind, right? We would see a flat bottom, potentially a straight line upward, another flat top, and then an angled line, which would represent this tilted wall that would go to this endpoint, right? So we could follow along that way. And then, of course, we notice there are these extra walls or arms. I'm calling this a couch. It's not really a couch, but it kind of looks like one because of the arms. Those are also extended outward from this angled slope. So we're going to draw a basic shape. It's not going to look exactly the same, but we're going to continue to adjust it until it gets closer to it. That said, there is not one right way to make a design. There are many different ways, and this is the choice I'm making is just because it makes sense to me in my mind. So if you can come up with another way to produce this design, that's okay. As long as you are consistent and your measurements match, then potentially you have followed the instructions. I'm not going to be generally picky about how you do things as long as it's a reasonable approach. And you understand what you did and it wasn't guesswork. So let's go ahead and start. We're going to continue to go back to this to reference our general shape. So in our 3D environment, we can see again our cube that kind of gives us the overall view. I'm going to click the home button, and this does allow me to see that I have a view of the front, the right, and the top. If for whatever reason yours does not have the Y pointing up and the Z to the left and the X to the right in your home view, then what you can do is in the top right, you can find the area with your initials, and mine says my name and my initials, and in this menu, click Preferences, and it'll open up a window for us. And in this window, the key that I think is important is where it says Default Modeling Orientation. Y is up. Yours may say Z is up. My suggestion, so you can be in sync with what I'm doing, is to choose Y is up. And if you have to change it, you can click Apply and OK, and then you may have to restart Fusion 360. And once you've done that and you're back, hopefully it'll be the same as mine. You can click the Home button. Again, the idea is that we can rotate freely and change our view, but if we want to kind of have a default view again, we'll click Home. So with that said, if we're all in line with this, we're going to go ahead and start by making a 2D sketch, a 2D drawing that'll have measurements and eventually be stretched into 3D. So in our menu, our application bar at the top, we are in the design workspace, right? And again, we're going to talk about some of these other ones, but for now we're in the design workspace. In that first category, create, there are some pre-built buttons, and we can always hit the drop-down menu, and there are many, many different options. We're going to create a sketch, so I can choose the second option, create sketch, or you can also see the same button is right here, create sketch. Either one of these is acceptable. So create sketch, or you go to the menu and create sketch. So I'm going to click on the button. We should notice that the three colored lines show up. These are the three axes that exist in our 3D world, and three planes that are generated by these axes. So notice this plane is tied to the YZ axes. This plane is the XY axes, and this plane is the XZ axis. Right, so this is just about orientation, so I'm going to choose this one. And again, as we hover over them, it kind of rotates that grid for us, but I want this one that is the YZ axis. I'm going to click it. It's going to rotate our camera, and now we are in a sketch view. We are in an open sketch. How do I know it's an open sketch? We have several kind of factors. The first, at the very top, an extra menu popped up, and it says sketch. We can see that we have different options. We have create, modify, constraints. This is another clue that we're in a sketch. Yet another clue, the finish sketch button appears. If we were not in a sketch, but just in our regular 3D environment, we would not see this button. And the last hint that we are in a sketch is the sketch palette. And similarly, there's a finish sketch button just like this one. But the sketch palette gives us some tools that we may use during our sketches. A sketch is just a kind of 2D view where we can draw 2D shapes and put measurements and connections, and the result will be the ability to make a complete closed 2D drawing of some form. So the first thing we're going to do is, again, I mentioned I'm going to do a rough trapezoid based on what I think the side view of this is. It's not going to look the same, and I see that you may not agree with the view, but I think that it's a reasonable approach to take. I'm going to click. And again, we have different options for 2D shapes we can make. We can use individual lines. We can make a rectangle, or circles, or arcs, which are partial circles. We can make complex polygons that are either inscribed in a circle or circumscribe around a circle, so they're around it. Or we can do it by edges. We can make ellipses, which are circles that do not have equal radii in 2 dimensions. And there's a few other more advanced ones. We're not going to touch these for now. So line, I think, is our best option. When I click on the tool or use the L keyboard shortcut, our cursor changes. We have a little crosshair, and we have a little symbol next to our mouse. That's that little hook. If you just hover in one spot, it says place to first point. The way a line tool is going to work is we're going to click the first point of a line, and then we'll see the kind of line will have a temporary view of where it is and what angle it's at and all this other information. And we can continue to click points and make connected lines, or we can stop at any point in time and then stop wherever our line happens to be. So I'm going to start off by hovering over the origin. This is the origin point. We see that circle and the little green square. I want it to be locked to the origin. I'm going to click on it, and notice it gives me some information. It says how long this line is in millimeters, and then the angle from the x-axis is another useful point of information. Again, we're not going to use this for now, but generally speaking, we could do this. So I'm going to put a line roughly up in some direction. For now, we're not worried about dimensions. We're just going to put the line visually. So I'm just going to go up. I'm going to click once. Notice how there's a point there. Now I have a second portion. And you may notice things snapping. It's trying to give us information. So it's saying, oh, these lines are collinear, or this is a horizontal line, or we may want a 45 degree or perpendicular line, a 90 degree perpendicular line, and so on. If I wanted to stop, I would just click on the little green arrow or hit escape on the keyboard, but I want to continue. So I'm going to make another shape. I'm going to click and go straight sideways. There's my second one. I'm going to go straight down, close to the x-axis, click again, and I'm going to do one more line. I'm going to go back to the origin. And when I click, if I did it right, it'll make a closed shape. The tool will no longer be showing me this line information. So here we go. I'm going to click back on the origin. And there it is. And notice now how my tool is kind of still on, but separate. And the shape that I created is like a light blue. To get rid of my tool, I'm going to hit escape on my keyboard. So now I'm back to my regular cursor. I'm going to zoom in a bit because this is a pretty small drawing, so I can scroll with my mouse, or I can use the zoom option at the bottom if I'm on a trackpad. But I want to kind of keep it roughly in the center of my screen. But now notice this shape is a rough shape. And again, my goal was that if we were looking at this diagram from the side, this is roughly the shape we would see, ignoring the wall. So we might, in reality, there might be a square wall here, but we haven't done that part yet. I'm just doing the core kind of shape that I saw in the picture. So some things to note. Constraints are the idea of rules that must be enforced on our shape. And by default, because I made my shape in a particular way, some constraints are given to us automatically. These are kind of, the computer's trying to be intelligent and say, you must want this constraint, this limitation, this rule on your shape. So the three that I notice outright, two of them look similar. This kind of angled T, this is a perpendicular constraint. And if we look at the menu, here it is, perpendicular. And hopefully you know from your math, perpendicular means that the lines are 90 degrees rotated from one another. So this is a horizontal line, so 90 degrees downward would be a vertical line pointing down. Similarly, if we look at this line, it's a vertical line, a perpendicular line, horizontal to the left. Right? So these are perpendicular constraints. These were done automatically because I made lines that were pretty straight. But if I didn't, I could force them by using the constraint tool. Sometimes it's automatic, sometimes we'll choose our constraints manually. Another constraint that happened automatically, and we can see that the little icon here, is called the horizontal constraint. And it's the first one over here. And what it says is this line must be horizontal. So I cannot tilt it up a little bit, I cannot tilt it down, it is a straight line. If I try to move it, it always stays horizontal. The shape will adjust to enforce the rule of horizontalness, right? Similarly, these constraints are also enforced. I cannot move this line in any fashion that would break the perpendicularness of this overall setup. And so these are what constraints are doing, enforcements of rules that cannot be broken unless we get rid of those constraints. And technically speaking, there is a constraint on this line, but it is not an explicit one. It's kind of hidden behind the scenes. And we can ask ourselves, what is, excuse me, that was a phone noise that should not have happened. So what is this implied constraint? And if we think about it, let's start from here. This line must be horizontal according to this constraint. The next line attached to it must be perpendicular, 90 degrees from it. This third line must be perpendicular to the previous line. And so the implication of the only kind of line that can be perpendicular to a horizontal line must be a vertical line. So this one has to be vertical. So I could have enforced a constraint, and I'm going to try it right now temporarily, and we'll get an error saying this is unnecessary. So I'm going to try it. And it actually immediately kind of did that. I'm going to try one more time. I'm going to click on this line, and if I look at this error, sketch geometry is over-constrained. It says, look, you may not know it, but I know that this line must be vertical. There's no need for you to kind of force it on the computer. The computer can do it intelligently. And it's pretty good about a lot of these things. So I'm going to hit escape to get rid of this tool. And so this one also, whether we know it or not, has a horizontal constraint. It's implicit. It's behind the scenes. Why? Because again, if I have a horizontal line and I have another line that's perpendicular, that line must be vertical. And if I have a line that is perpendicular to a vertical line, it must be horizontal. So whether I know it or not, this line is horizontal. It cannot be any other way because of the summation of these constraints. So the last constraint that we may not see, and it's probably the least obvious and often one of the most useful, but it's done behind the scenes a lot of times, is this shape right here. And this is called the coincident constraint. If I look at the menu at the top, it is the second one, coincident. And if we read what it says constrains the position of 2 points or a point to a line or a point to a curve. Essentially, we're saying if we have two vertices and we make them coincident, they must be in the same location. This is essentially what snaps lines together. A line is two vertices connected by an edge, right? So a shape is multiple lines where all of their vertices are coincident at some point. So there are actually two vertices here, this one from this line and one from this line, and they are coincident with both each other and the origin. So I cannot move this point. If I try to drag it, nothing happens. It stops me. It says, nope, you are locked into place. Here, there's another coincident point because it's the end point of this line and the starting point of this line. And there's another one over here, and there's another one here. And notice when I click on them, they have this little symbol appear. It's saying there are coincident or locked together vertices. Right? And that's an important concept, and we often can do that either manually, which is not as common, or kind of implicitly when we make shapes. Okay, so I think the next step is going to be to dimension this because, great, the shape is roughly correct, but we want to match dimensions properly. And so there is a tool that's going to allow us to dimensions. The first one I think that's the most obvious is this bottom line. From the front all the way to the end is 26 millimeters. So if we come back, that's this line. It should be 26 millimeters. How can I dimension? How can I tell it what size to be? I have two options. If I go to the Create menu on the top of my Sketch application bar, the last option is Sketch Dimension, or D on the keyboard. So I often will just hit D on the keyboard, and it gives me this dimension tool. Just so we know, notice now what happens is, and I didn't mean for it to actually click on this, so I'm going to click away and try one more time. Our mouse turns black, and there's a little symbol that has like the dashed or the arrowed line on it, and that's a dimension tool. And notice what it says. It says select sketch objects to dimension. So we can pick an individual line, we can pick two lines, we can pick two vertices, and it's going to intelligently decide or attempt to decide what kind of dimension we want. If I click a line, what it's going to think is, oh, you must want to tell me how long this line is. So I'm going to click on this bottom line, and then it gives me the number that it currently is, and if I'm allowed to, because there are no other constraints, I can type in a number. So if I click one more time, it lets me type it in. So I'm going to type 26, and that is millimeters by default. So if I hit enter, notice it got a little bit longer because I was pretty close. I had done 24 point something, and so now I'm at 26 millimeters. And notice this thing here is just as a reference as a dimension, so I can always double click on it to change the number if I want. Or I can leave it alone, and I can always move it around if it's in the way. So if I want to see this better, so 26 from here to here. We'll also notice as we force dimensions, lines will change from blue to black, and these means that they're constrained enough that they cannot move. So I cannot grab this vertex and drag it because if I try to pull it this way, that would imply that this is not the correct measurement. But I've told it must be 26. I can't bring it in because that would make it smaller, and it can't be done. So the constraint dimensions are a form of constraint, limitation, saying you must be 26 millimeters. Another dimension we might have, so I'll point out, we could dimension this one, but I don't know the length from my drawing. This angled line, its length is not apparent. It's this slope of this wall, but I don't know how tall it is. So we don't necessarily always have all dimensions in our drafts, but we can probably calculate it, or if we do it correctly, if we put other constraints, it may not even be necessary to dimension it. So now let's try aiming for the height of this thing. So from here to this cutoff part is 21 millimeters, but if we recognize that this is actually the tip over here that our drawing is, the total is 21 plus 5, which is 26. So we're going to come back, and we're going to dimension this line as well. So I'm going to click it once. And this is much too short, so it's 17. I'm going to click on it, and I'm going to type 26. And there it is. And again, notice, of course, for this one to get longer, that means this one had to get longer, and then this kind of shrunk. And so now the last dimension, I'm going to zoom in a bit, is this potential top line. So let's look at our drawing. And this line, which we don't have a dimension for, is not the top. It's actually this point from here to here. And if we look along our drawing, it is 5 millimeters. So let's go back to our thing, and let's choose our sketch. And let's choose this top line. And mine's only 1.17. That's way too small, so I'm going to type in 5. And now it stretches. And now notice this last line automatically turned black. Why? Because it is constrained completely. If I hit escape so I can get rid of my dimension tool, and I try to move anything about this sketch, I grab this vertex, won't let me drag it. I grab the line, it won't let me drag it. This sketch has enough information to know where everything belongs, right? We're locked to the origin right here. These lines are perpendicular. This line is horizontal. By implication, this line is also horizontal, and by implication, this line has some length, and I don't know what it is, but I don't have to, right? The fact that I have these two dimensions and this height automatically can have the computer calculate this length. If I'm curious as to what it is, I could potentially use some tools to see it, but at this point, I am not interested. It's unnecessary to know. And it wouldn't even allow me to choose a dimension because it would say it would be over-constrained. The information is hidden behind the scenes, and it doesn't need us to help calculate it. So we are completely done with this sketch. This is a 2D drawing, but we're going to make it 3D shortly. I'm going to click Finish Sketch, either here or at the top with the green button. And notice what happens is we go back to our original view, and we see that this 2D sketch is actually in a 3D space. So I'm going to rotate my camera on purpose, and we can see that like it's actually a 2D drawing in a 3D space. So it's like this infinitely thin kind of slice of a drawing, and so it's not really 2D, or it is a 2D drawing but in a 3D space, and we're going to hopefully stretch it out and to make it 3 dimensions. So something else to note, and I mentioned this in the previous video, as we construct things, sketches and 3D bodies and objects, menus will or folders will show up in our browser. Now we can see right now that a new folder called Sketches has appeared. If I hit the little arrow, the white arrow on the left, there's our first sketch. We can relabel these if we want. If I right click on this, and I can say rename, or I can edit it. Well, actually, there's no rename button here, but if I click on it once loosely, it lets me type in a name, so I can actually change the name of the sketch. I'm not going to do that. I can hide it, so if I don't want to see it for some reason, and as we have more things, we have reasons to hide things, I can always hide the sketch. Even though it's not gone, it's just invisible, and I can kind of bring them back with this eyeball, either one of these. And so now, with this sketch, this is great. We also notice in our timeline at the bottom, and I mentioned we were talking about parametric modeling, in our timeline, we are saying this is the first thing that we did. We created a sketch. So if I were to go backwards in time, it would go before the sketch was in existence, which would be the very beginning of our project. So let's go and try to make this 3D as our next step. I'm going to go back to our drawing and ask ourselves, if I made a flat 2D drawing, how thick should it be? And what is the third dimension? And if we look along the bottom edge here, I think we can recognize from this corner to here is 7, from 7 to here is 39, and from here to here is 7. So we sum all 3 dimensions. 39 plus 14 is going to be 53, right? Because 14 would be 49, and then 4 plus 9 is 3, or 13, so 53 millimeters, right? So let's go back and stretch this into the third dimension. Since we're not in a sketch, our menu is back to the original. In the Create section, the first 3-dimensional tool we have is called Extrusion, or Extruding. E is also a shortcut on the keyboard. We can press the Extrude button, or it's also the second button in my menu right here. And it gives us an example. It says you can take a 2D profile or sketch or face of a 3D object and pull it out or cut it in to the third dimension. So we're going to choose this button. As soon as I click it, since I had this selected, it does turn blue, and it gives us this little arrow. And on the right side, we have the extrusion or extrude menu. There are a lot of options we're going to look at. So if I just do it manually, if I drag this, we can see that it pulls it out in 3D. And I can actually go either direction. And notice it tells me how far I did it. In this case, if I go backwards, it's negative 18 millimeters, but that's the negative is just the direction, not the actual magnitude. And similarly, if I go this way, it's positive 18 or whatever it might be. We said 53 millimeters, so I could go all the way down to this way and go to 53. That's not unreasonable, and that's not bad. But I want to try some other things. I want to take advantage of symmetry, because if we notice our drawing, it's symmetric because there's a cut on the shoulder here and a cut on the shoulder there. There's a wall here, there's a wall here. So to take advantage of this symmetry, instead of only dragging the dimension to one side, I can change some options in my extrude menu to make it so that it goes evenly on the left side of the blue line, or our z-axis, and the right side. So it's symmetric across the z-axis, and that's a good thing to have for future edits. So some choices we have in the direction section of the extrude menu right here. One side is the default, so it lets me pull it one way. There's 2 sides. Notice now there are 2 arrows, so I can pull this one some amount, and this one some amount, and I can get this, and the sum would be the total distance. So for example, if I wanted to have 53, what should I pull them to, right? Half of 53 would be 26.5. So I could manually drag it to 26 and then type in the 0.5 right here. So 26.5. And similarly here, same thing, instead of 24, I could do 26.5. And the result, oops, get rid of the decimal point, is 26.5 and 26.5. The sum is 53, and it is symmetric, and that's not a bad choice. But typically we choose the two-side option if we're going to have different lengths. So for example, if I wanted it shorter on this side and longer on this side, then we would choose two sides. If we know it's going to be even on both sides and we want symmetry, then the third option is the best option, and it is symmetric. So now immediately notice there's back to one distance, and if I pull it out on one side, the other side automatically stretches. So this is symmetry to our advantage, and so I can type in 26.5 as my option, 26.5. And there it is. And the sum total will be 53 millimeters. So operation is new body. It's kind of the main one we're focused on. It's going to create a 3D body. So I'm going to click OK. And we'll talk more about some of these other ones later on, but right now our advantage is that we don't have to do much else. I'm going to click OK. And the result is a 3D object. I'm going to rotate around it freely, and we can see there it is. It's a 3D kind of trapezoid. It's the starting point of our, if I go to the home view, it's sort of the beginnings of our sketch. Again, it's missing this piece and this piece, and it has all this extra stuff, and it doesn't have a hole yet, but we're getting there. So we can continue to edit. Some other things to point out. We're going to recognize that the original sketch, if I hover over it in the browser, it does highlight it, and it's invisible right now, because typically when you use a sketch to make a 3D body, it says, oh, you must not need the sketch anymore, let's just hide it away from you. It doesn't delete it, it just makes it not visible. And so we can always come back and bring it back. If I really wanted to see it, there it is. There's the sketch that was the basis of our 3D shape, but it hides it by default, and so there it is. We also notice in our browser, on the left, we have a bodies folder now. If I open it up, body 1 is this 3D object. That is the 3D object. And the final thing I will point out is in our timeline, we can see there's the original sketch, there's the extrusion. So that is the steps that we've made so far. And I'll be able to slowly go backwards in time if I drag this bar to do all kinds of different things. We're not going to do it just yet, but we might in the future need to do so. And this is a very good tool to have. And the parametric design really allows us to be flexible in our choices. I'm going to stop this video now as in the final step of saving this, and we'll continue with the next set of steps in another video. And so the last thing I'm going to do is I'm going to do the File menu, Save option for my design. It's going to ask me for a name. I'm going to call this, and so you may call yours Couch. I'm going to call mine Another Couch, because I have a design originally that was called Couch. I don't want to mix up the names, but we're going to call it Couch. It's just a name. And notice it tells me it's in the CAD project folder and notes. So your project folder, whatever yours is named, notes. I'm going to click Save. And in a moment, it'll show us this. There it is. And it says version 0. This is the first time we've saved it. Every time we save, we have a different version. And if I check my data panel on the left, there it is. So there's my original couch. This is the one that we're working on right now. And this one was on version 5. This one's now currently on version 1. It's the first save. And so we'll come back to this in another video, and we'll continue to expand on this 3D object. I look forward to seeing you in the next video.